Welcome everyone. Thank you for joining AI Loves Analytics Meetup. The best automation predictive analytics tools is something that we're going to discuss today. Please follow the channel and subscribe it if you haven't done so already. Let's quickly jump to our demonstrations. We will take some interesting use cases and showcase the Cloud Pack Data version 3 on power systems, some of the very good tools for predictive and prescriptive analytics. Thank you and welcome all. We would go to a data platform called dataplatform.cloud.ibm.com. Over here, you are given a choice to either activate Watson application with your existing IBM Cloud account, or you could register for a new cloud account. I simply logged in using my existing credentials. Upon login, I'm at the Watson Studio screen made available under Cloud Pack Data version 3 on Power Systems. Over here, I see a dialog of Knowledge Catalog. Once I click on Try it for free option, I am able to see different price plans. The 5 price plans are: first, Lite, which is available for free. Second, a Standard, that includes 50 free catalog users. Third, a Professional, that includes 500 free catalog users. Fourth, SQO Standard, that is ordered directly through IBM Sales. And fifth, a SQO Professional, which has same features and is included under professional subscription-based pricing. For demo purposes, I am choosing the Lite version that is available for free. The Lite plan for Watson Knowledge Catalog offers everything that we need to begin our journey in becoming a data-centric organization. As I click the Create button, a Confirm Creation dialog box appears. This awaits input from the user about the choice of region, plan, resource group, and service name. For now, I would leave it as is and press Confirm. And creating a choice of instance, we are at the welcome screen of IBM Studio and Knowledge Catalog. This is where you will work with data to find insights and build models. Watson Knowledge Catalog is a place to find the data and other assets of need. We create projects for working with data for a particular task. We write code on interactive environments for custom functions. We can surely add data and collaborators to the projects. A catalog, by definition, is a means of storing assets and finding them. Joining on an existing catalog enables you to search for useful data or analytical assets. You also have a choice to create a catalog and start adding assets and collaborators to it. Projects. Let's discuss projects. We can either create a new project using this new tab, or we could explore the projects over here, created by me. Think of these projects as containers. These containers also store our related assets. To access these assets, we can launch Jupyter Lab IDE or RStudio. We can choose to manually write code in the notebook or IDE, which is an interactive development environment, or we can also use a SPSS modeler to leverage recommended transformations or functions for productivity. Augmentation requires the use of decision optimization that basically means giving user an option to include or exclude features. In today's session, we will also see and learn to use Auto AI with the push button, which is an integral part of automation, defined under Data Science Automation Productive Spectrum. We will learn to harness the power of artificial intelligence, and scale with IBM Watson Studio. While we explore this product in detail and create unique projects, those increase productivity for data scientists, analysts, developers, and subject matter experts, we will find out why it's the world's best AI. Benefits of Auto AI are we can get started with a couple of clicks and without coding. We can extract more predictive power from our data with auto feature and engineering. Auto AI enables us to easily compare candidate pipelines to find the best model for the job. This is simply a one click deployment to IBM Watson Machine Learning. Machine learning and AI models are used to provide insights into the business to provide better services and products to customer. Creating models can be time consuming. If you do if you do it through notebooks or through our studio, you'll have to decide which attribute to use, deal with absent values, and convert all the attributes to a format that is acceptable to the chosen algorithm. Then you will have to try different algorithms to find out which one performs the best. There is a better way. Watson Studio includes a tool that can make this task faster and easier, called Auto AI. Here we will see our studio session. Inside this R Studio session, we can import the dataset and start writing our code manually. As you see, there is an option of importing dataset from text, from Excel, from SPSS, from SAS. Also, this is your terminal. You can update packages from here to the environment. In the next step, we'll select the dataset to use and then take a look at the input data and ask the Auto AI feature to select the prediction column. We just looked at the R Studio. Now, let's launch Jupyter Notebooks. The Jupyter Notebook is an open source application that allows us to create and share documents. Those contain live code equations, visualizations, and narrative text. Jupyter is a web based interactive computational environment for creating programs, and its name is a reference to code programming languages supported by Julia, Python, and R. Inside the notebook, when we open it, we notice that it contains a cell. Cells are a way how notebooks are structured. These are the areas where we write code. To run a piece of code, click on the cell to select it, and then press Shift plus Enter. Or press the play button in the toolbar above. Let's look at one of the fascinating use case of streamlining marketing. Upon learning the basic functionality of running programs in Jupyter Notebooks, let's discuss this problem faced by the marketing department of a company. This department is facing a situation where they need to select some individuals from a customer base. This marketing department needs to figure out who and how many of the customers needs to be selected to be participating in a promotion. The marketing department also has to find out the best communication channel, like newspaper, etc., that these customers shall be more receptive to, in order to ensure increased sales and for their product success. The marketing department also faces a budget problem and needs to have a better understanding about spending their dollar. With a limited budget, they're supposed to promote selected financial products to their customers. This notebook lies under one of my projects as a use case. This particular use case will give us visualizations and a structured understanding of our data. We are provided with two data sets. Number one is the data set of individuals or customers whose behavior is known. Think of them as old customers. And then data set of individuals or customers whose behavior is unknown. Think of them as new customers. Under this use case, we combine predictive and prescriptive analytics. I'm using these Jupyter notebooks to demonstrate classification of customers, predicting their behavior, forecasting demand. This use case study is a fairy tale bank in year 2018 that follows the merger in 2019 under a budgeted campaign, and the bank wants to contact their customers for marketing. Our problem statement is to design a solution for the marketing department in order to better understand how they should contact or propose a product, how they should be contacting the customers, and what are the best ways or optimal use of their limited budgets in order to make the profit. Now, I have divided this problem into separate parts. To begin, we'll go through the following steps. We'll train the machine learning project based on classifier to profile a customer. A customer who would subscribe to a mortgage savings or a pension account. This is basically profiling on basis of behavior. We will now apply predictive model to a new customer who cannot be profiled because of lack of data. In order to predict for each new customer, we will understand their buying behavior. We'll check out the 2018 customers, provide some visual analysis of the historical data, do a scatter plotting for savings, mortgage, and pension, understand the 2018 customer, see that the customer's income is greater, more likely they're buying out a savings account. We train a model to predict customer behavior, prepare data and select features to be used. Now, these variables, they play an important role. We have to find a correlation for building a model among these variables. And we can also do feature engineering using these variables. Now we'll create and train one simple model for each product. As I mentioned, we will apply a predictive model to a new customer whose profile cannot be created because of lack of data. So this is predicting the new customer behavior. We are just plotting the cloud points for offers, savings, mortgage, or pension. The training data contains customers who bought more than one product. Take a look at the prediction. So this is just the shopping behavior. Now, in the third step, we will apply a decision optimization model to offer a product. Our goal shall be to select a customer and the best channel to contact them. This is decision optimization C++ modeling for Python. This is setting up prescriptive model, do cplex.mp model. These models are defined so we can even find their definitions, adding constraints, expressing our objective using a for loop, setting up key performance indices to be used for reporting, solving the decision optimization model. Finally, we will display our analysis as solution. In the solution, in the output, we see that a customer we chose has a customer ID as 11 and we are offering him a savings product as a gift. Likewise, we chose 46 other personals. We're also able to run what if analysis, that is, if determining the value of budget threshold. For a large data, the maximum number of customers is 1677. Those can be reached, and anything over $35,546 we would not be able to spend. The corresponding revenue number for the original data set is $87,120. As you see in this notebook, using machine learning, we have predicted some customer behaviors, and using decision optimization, we have prescribed the next best actions. This is the power of AI. Now let's move on from predicting customer interest to optimizing a campaign with machine learning. We will now try to find out the customers, those can be included in the promotions, using an auto AI experiment. Machine learning and AI models are used to provide insights into the business, to provide better services and products to customers. Creating models can be time consuming. There are multiple ways to build models. There are even multiple tools of automation and to carry out experiments for statistical analysis, such as H2O.ai. You could use RStudio, Python, or any other programming language individually to leverage model computation on your data in a system, and even you can do it through a notebook. First step, once you plan to import the data to your environment, you have to decide which attributes to use. Deal with absent values and convert all the attributes to a format that is acceptable to you for the chosen algorithm. Then you'll have to try different algorithms to find out which one of them performs the best. There's a better way. Watson Studio includes a tool that can make things and this task faster and easier. It's called Auto AI. With the Watson machine learning service as a part of our project, we add an Auto AI experiment to it and give it a name. A description, we have a Watson machine learning service instance. Our compute configuration is here. We select this compute plan and click create. In the next step, we select the data set to use. Auto AI then takes a look at the input data and asks us to select the prediction column, which is customer ID in our case. Once that's done, click Run Auto AI Experiment. Auto AI goes through multiple steps, it splits the data, pre-processes it, and then moves to model selection. In our case, we are dealing with a classification model. It chooses from a list of 30 potential candidates. In our case, we are dealing with known behaviors. This is the data of old customers. We are choosing from a list of old customers. You may recognize a few of these algorithms when it comes to selecting algorithm. For example, we see the decision tree, random forest, XGBoost, gradient boost, etc. Gradient boosting is a machine learning technique for regression and classification problems. This produces a prediction model in the form of an ensemble of weak prediction models, typically decision trees. Now, in statistics and machine learning, ensemble methods use multiple learning algorithms to obtain better predictive performance that than it could be obtained from any of the constituent learning about them alone. Multiple pipelines are built in this experiment. Let's say for inference, pipeline third is for accuracy. First, data is getting trained from known behaviors. We are building a relationship map for prediction. Customer ID, as we mentioned, before the first step of training for data for known behaviors. The second step is choosing or selecting an algorithm among top algorithms, then working on pipeline for accuracy and different feature selections. Then normalizing data or doing feature transformation on data. Feature engineering includes classifiers, transformation of data, pipelines, and several other features. The experiment starts with downloading source data and selecting algorithms for pipeline generation. Using 10% of training data, discarding underperforming algorithms and keeping the top algorithms. We'll complete feature engineering for pipeline, optimize the model, start the model, transform data for pipeline, complete hyperparameter optimization, complete model optimization, complete feature engineering. Now, which one is the best for our situation? If we're dealing with regression model, Auto AI would select from a list of 44 algorithms. These may include ARD, stands for Automatic Relevance Determination. It is prediction by expectation. Elastic Net and Lasso. Lasso is a regression analysis method that performs both variable selection and regularization in order to enhance the prediction accuracy and interoperability of the statistical model that it produces. RMSE in this case is root mean square error. It represents the sample standard deviation of the differences between predicted values and observed values, also called residuals. Which algorithm would be the best for you for a specific situation? Do you know them all? Back to our modeling. Auto AI tries the algorithms, tunes some hyperparameters, even does additional feature engineering to find the best model for the dataset. Experiment is completed and 8 pipelines are generated. 8 pipelines generated from algorithms. You can see the you can view the full log here. Gives you the details on what are the steps that are done, how much time it takes. The root mean square error. This is the optimized model. A root mean square error interpretation is that it indicates the absolute fit of the model to the data, meaning how close are the observed data points to the model's predicted values are. The lower the value of RMSE indicates a better fit. In our case, it is customer ID. We can choose other variables as well. I have chosen mortgage as one of the financial products to be proposed to the customers in a previous example. Once we are satisfied with the model, we can save the model into WML. We can see the model saved under Watson Machine Learning Models. We can also decide what we want to do with our models: publish it to a catalog, deploy it, or delete it. Deploying an Auto AI model in Watson Studio is just like deploying any other model saved in Watson ML. Simply select Deploy. Once there, click on Add Deployment, give it a name, and deploy it. It takes a few moments to create the service, and then the scoring endpoint is available. Watson Studio provides information on the model. Under Implementation, it provides example code for multiple languages. Example: Java, JavaScript, Python, Scala. Remember when we made a model using Python Notebook for our previous use case? Over here, we do not have to write that code ourselves. We can leverage Auto AI for that functionality. The Test tab allows the user to use a JSON representation of a record and receive the scoring result as a JSON document. This way, users can easily evaluate if the scoring is as expected. Auto AI can speed up the selections, development, and deployment of machine learning models. It provides a faster path to insights for AI infused applications. We can view the details of the models of our choice. This starts with evaluation. That gives us the details of how the models are performed. Root mean squared error, the value of r squared, explain variance, mean squared error, and several other attributes. We also can see the model information. The customer ID, the number of features considered in building this model is 22. Now keep in mind, not all the features or not all the variables would be relevant. So with feature importance, what was most relevant in making this model is defined here. In this case, it is income. Things like this can be seen from the model attributes. So now we conclude today's session, and finally I so very much thank all of you for joining today. On the screen there are some useful links for more learning, demonstrations, free trials and support. Please feel free to contact me via Media Messages or LinkedIn for questions around predictive or prescriptive automation. Stay safe and keep watching machine learning. Thank you.